5, 4, 3, 2, 1.
I bet you were wondering how we got here. So sit back and enjoy the ride.
ME 2110 is an introductory design course for mechanical engineering students at Georgia Tech, which puts them to the test by challenging them to form teams and make a device that can handle several objectives in a 45-second time frame. This year's theme is Mission to Mars, based on the movie The Martian, starring Matt Damon. As a result, each of this semester's objectives are based off this film. Contestants must remove radioactive elements from their color zone. Any remaining elements at the end of the time will count as a 6-point deduction from your final score. Next to the rocks. Moving these back into your safe zone from your home zone will secure you 18 points for each rock entirely in your safe zone. Further, teams are given the chance to land spacecraft in safe zones for 15 points each. Watch out though, if you land in unsafe zones, you'll score negative 20 points for each spacecraft that lands in an unsafe zone. Teams need to deposit or hoist a flag over the center section to gain 60 more points. Lastly, to make it home safe, you need to retrieve astronauts and rovers into your home zone for 28 points each. That's all for the competition. Now time to get building.
Moving on to the specifics, here's an overview of our design subsystems. The final subsystem is the radioactive element removal system. A block of wood is screwed into the base of the box in order to raise the final drawer slide off the ground. Attached to this drawer slide is a flat piece of wood with 2 smaller pieces screwed on top of it. On the sides, 2 planks of wood are attached by hinges, therefore allowing them to move about an axis. When this subsystem is fully closed inside the box, the side planks rest against the side panels of the main box. The 2 PVC pipes rest against these planks on each side of the platform. When the drawer slide is pushed out by an actuator, the side planks drop due to gravity and the 2 PVC pipes roll into the arena, clearing the radioactive materials. In order to deposit the spacecrafts, a PVC pipe was attached to an additional drawer slide on the top subsystem. Attached to the PVC pipe is a block of wood, longer in length than the pipe, to ensure that the pipe does not hit the cylinder as it rotates around. In the same way as the top drawer slide, the subsystem shoots out, pushed by an actuator, to the center of the arena to deposit the spacecrafts into the safe zones. One of the first fail points that needed to be addressed dealt with the astronaut and rover retrieval system. Each time that the arm collected the astronauts and rovers, the pieces fell into the drawer slide, while still remaining partially on the rotating cylinder. This earned us 0 points. In order to address this, a section of cardboard was taped onto the drawer slide. Attached to the same drawer slide is the flag deployment subsystem. A long, thin strip of wood is attached to a mousetrap held in the downward position by a string tied across the top of the box. When the device is deployed, the drawer slide slides forward and the flag automatically shoots up after moving past the string. It then holds the flag above the center cylinder of the arena, enough to earn the full 60 points each time. A third struggle faced while designing the machine once again dealt with the astronaut and rover retrieval system. This fail point resulted in 0 points gained for the collection of astronauts and rovers. To address this, a section of the block used for collection was cut off to ensure that it did not hit the cylinder before being fully extended. And while boxing the device, it was discovered that the device was too big. To address this, the top of the box was cut off, therefore allowing it to fit into the go-no-go boxes. This solved the issue for one competition, but to ensure this problem did not resurface, the exterior of the box was sanded extensively.
Here's an overview of how we got to the final competition. First, in the rock collection competition, the machine collected 1 full rock and 3 partial rocks into the home zone out of 9 total rocks. This scored us 54 total points. During the Mountain Ridge competition the week after, the machine retrieved 2 rovers and 2 astronauts each round, earning us 336 total points. In the qualifying round, the machine scored 36 points, 54 points, then DQ'd the final round because of the evil black box. This led us to entering the final competition seeded 38 out of 61 teams.
Now for the results of the design review. We had numerous compliments from students, TAs, and instructors on the quality of our poster and the painting ideas, but we unfortunately placed 51st out of 61 teams in the design review. And now for the final competition. The first round went perfectly. We scored our expected 88 points and gave us a chance to use the second round to explore improvements, including machine positioning and in-the-moment decision-making involving spacecraft. We scored negative 98 points in the second round, leading us to the realization that our improvements weren't really helping. Unfortunately, we came in third place with 78 points in the third round, failing to secure 2 rovers that proved to be the difference maker. Over the course of 3 rounds, we competed against 3 of the 4 teams still standing in the final round, with 2 knocking us out in the third round. So you tell us how we did overall. All in all, this course proved to be a cornerstone in our development as team members, engineers, and global citizens. Not only did we have an opportunity to dabble in advanced design techniques, but also expanded our knowledge and gained experience using machinery and other fabrication tools, which are valuable resources to future employers. Thank you for joining us, and we hope you've enjoyed Win-terstellar's Mission to Mars.